What we have is question 3, okay? So, we know it's not a sine rule, but sometimes you don't know it's not a sine rule. So we're going to attempt the sine rule first, okay? Sine rule, you go to your test, you go A over sine A equals B over sine B. You won't have the luxury in a test of going, oh look, I'm in the cosine rule chapter, it has to be a cosine rule. So if we tried the sine rule, what would we have? Sine 65 over, or A over sine 65, that's grand. Then I have to pick another side, so pick one of the other sides. 11. And because I don't know this one here, I call it angle X. That's very common. And then you look at it and you have two letters in the one equation. When that happens, you can't use the sine rule. Okay, so you have to go to plan B. Page 16 of your tables will give you plan B. Plan B is that you write down the cosine rule, which is a squared equals b squared plus c squared minus 2bc cos a. Is this question a length question or an angle question? In a length question, they're really easy and you just put them into your calculator. The angle questions are considered the harder of the two. So you looking, guys? So we're going to say A is a squared. What's opposite the A? What angle's looking at it? 65. So that means 65 is big A. Alright, and B and C don't matter. You can just call. I could call C7 and B11, or the opposite way around. It doesn't matter. So what you have here is something squared plus something squared minus 2 times something cos 65. You got to put in your 7 and 11 here. 7 and 11. Okay, and you're going to put all of this into the calculator exactly as it is, all in one big line, like that. And what do we get? 101.92. 101.92, Dennis?
Yeah.
Okay, a squared equals 101.92. Now that's a squared, not a. So what's a going to be equal to?
10.24.
Yeah.
10.24.
Yeah. And guys, just be aware, like, imagine this length is 100. It'd be completely out of scale, wouldn't it? Because 11 is this length here, and if your length is 100, it's all over the place. So just be aware of the size of your triangle as well. Does it fit in or does it not fit in? Is everybody happy with that? Yeah. How many people got that yesterday? Number 3? Okay, the majority, well done. We're going to go to number 5. Now, number 5 is an angle question. Once again, how would you know to use the sine rule? You don't. How would you know to use the cosine rule? You don't really. So before we even start, we're going to attempt the sine rule, just to prove that we have to do the cosine rule. You pick your angle A, and you pick the side opposite it. So you get 6 over sine A, and then that equals, pick another side. 5. Both 5 and 7, you don't know the angle opposite either one. So you call opposite 5, you can call it X. And once again, what's the problem? 2 letters in the one equation, can't do it. It's impossible. Okay? So when that happens, you once again, you go to your cosine rule. Now, what did we say this was? An angle question or a degree question? Angle question, okay? The angle is located here. And what's the side opposite the angle that's? The 6. This means that this one here, cos A is still A, and small a is 6 squared. Then what about B and C? Lads, what about B and C? 5 and 7. 5 and 7? Sorry lads, excuse me. Excuse me. Okay. Now, next thing here guys is, what did I ask you to do yesterday when you're doing an angle question? I gave you very specific instructions about what to do.
Leave the minus 2bc cos A on its own.
Leave that on its own to the very end. Okay? And then multiply everything else out and move it over to your side. So what's going to happen is I'm going to multiply these out and send them over to your side. So it's going to be 36 minus 25 minus 49 equals. Now I'm just going to put this part in the calculator, the part I underlined in red. and it's going to be minus 70 cos A. Then when I add the 3 then together, what do I get? I get minus 58. 38. Yeah, sorry. So minus 38 equals minus 70 cos A. If this is an angle question, what's the last thing we do for this angle question? Cos inverse, right? Before we can do cos inverse, we need to find out what cos A is. So we bring down the 70 underneath the 38, so it's minus 38 divided by minus 70 is cos A. So what's that in the calculator? Minus 38 over 70?
0.54.
0.54. So that's equal to 0.54. And then what you do after that? Cos inverse 0.54. And what do you get? 57 degrees. Many people got that one. 57.
57.
Yeah. Come on, Dennis. Okay, lads. So that's your cosine rule and sine rule explained. Now, going to move on to the next one, which would be number 9. Okay. Now, number 9 looks quite hard. Okay, but what it basically is it's 2 questions in one. So it's actually not as bad as you think. So what we're going to do is we've only been dealing with triangles, and we'll continue that trend. So I'm just going to join that one to that one, and now I have 2 triangles as opposed to one random shape. Now ask me to calculate the length of BC. Let's call BC x. Once again, we'll go to the sine rule. Can we do the sine rule? Let's check it out. X over sine 120 equals 3 over, call it m, we already used x as the length. And once again, what's the problem here?
2 letters.
2 letters, no good. I think it's a good thing I always start off with the sine rule, see if it can be done using the sine rule, and if it can't, go to the cosine rule. A squared equals b squared plus c squared minus 2bc cos A. Okay, what goes in the A's position?
X.
What we're looking for? X squared. What goes in the capital A's position? Cos 120, the angle that looks at the X. And then in the B and C position? 5 and 3. And then put all that into the calculator, square root it, what you get. So all of this in one big line goes into the calculator.
Wait, sir, are you looking for an angle, not the length?
We are look. Read the question. Calculate the length of BC.
Oh.
This is a length question. It's all right. What do we get?
49.
Is that x squared equals 49?
Yes.
Okay, guys. X squared equals 49. X therefore equals the square root of 49, which is 7. So, x equals to 7. Okay, guys. Find the measure of the angle BDC. BDC. Pick a letter, any letter you want.
Z.
Z. Okay. Use the cosine rule again. Except this time, what's going to be the angle? The angle is going to be Z, and the small a is going to be 7, because that's what the Z is looking at. Okay? So, somebody call me out this equation now with the numbers filled in.
7 squared.
7 squared equals a squared plus. Yeah. Yeah. Yeah.
Cos 120.
Cos.
Z.
Z. Okay. Like last time, bit of a protective barrier around the Z because we don't want to make the mistake there. So what we do is 49. Bring over the 8 squared, it's minus 64. Bring over the 4 squared, it's minus 16. Multiply this part out that's underlined in red into your calculator. We get minus 16 times 4, minus 64. Cos Z. Put this part into your calculator, what do we get? Minus 31? Yeah? Now guys, whole point is to get cos z on its own, and upon getting cos z on its own, you get z on its own. So what do we do next? So 31 over minus 31 over minus 64 equals cos z. What's that in, let's say, decimal form? 31 over 64. Was it? 0.48, yeah? So cos z equals 0.48. Cos inverse the answer. And what you get? What?
61.3.
61.3 degrees. Okay lads, so we've done all the way to question 6, haven't we? So I should probably be looking at 7, 8 and 9. And I need another one. Yeah, I'll go for it. Just a second. Okay lads, 1 second.